Imagine pouring creamy coffee milk into every ocean basin, from the Pacific trenches to the Arctic shelves, replacing salty water with a sweet. Right away, you feel the viscosity spike. Coffee milk is almost 10 times thicker than seawater. Currents that once raced along the Thermolean conveyor now crawl like syrup. The Gulf Stream sputters and Europe shivers as warm water delivery grinds to a halt. Meanwhile, surface sunlight meets a lighter, more reflective layer. Pure seawater absorbs about 94% of incoming solar radiation. But coffee milk, with its fat and suspended coffee particles, bounces back closer to 25%. Less dark ocean means more sunlight reflected into space, nudging global average temperatures down by roughly 1 to 2 degrees Celsius. At midday, the tropics darken under a pale tan, lowering evaporation rates, cutting moisture for rainforests, and shrinking monsoon rains across Asia and Africa. Deeper down, stratification rules. That extra viscosity locks warm surface coffee milk in place, starving the deep ocean of heat and oxygen. Phytoplankton, the microscopic factories of carbon capture, lose vital nutrients because upwelling stop. Their populations crash, and the ocean's natural CO2 sponge slumps by nearly half. Atmospheric CO2 rises again, partially counteracting the increased reflectivity. In the polar zones, sea ice grows faster atop the thicker, milked-up surface. Antarctica and the Arctic pack more ice, boosting planetary albedo even further. Summers shorten. Polar bears and penguins claim ever larger beaches of ice. Down in the Southern Ocean, the slowed circulation trap cold water near the surface, creating a giant, frozen lid that persists through each long winter. On land, where the patterns spin out of control, there's a bell-shaped north and south as jet streams wobble over a weaker temperature gradient between equator and pole. Europe's winters, once warmed by ocean heat, turn bitter. Monsoons become unpredictable. One year, massive floods across India. The next year, a drought that withers crops. Yet, paradoxically, equatorial seas under that milky canopy warm by half a degree. With slower mixing, the top 10 meters trap more solar energy on calm days. Cooking coral ecosystems supposed to thrive in warm water, but collapsing under the sweet brew's low oxygen. Our coffee milk ocean salt experiment shows a planet that darkens then brightens, cools then warms, freezes then bakes. Currents stall, carbon sinks fail, and weather dances to a brand new chaotic tune prove that even the most absurd ideas can teach us how delicately balanced Earth's climate really is.